So how does authentication work then? We have our server, Firebase in this example, but can be any server, and we have our Flutter app. And of course, the goal is that these two communicate and that we might have certain requests we're sending from the Flutter app to the server, which actually should be protected. For example, placing an order or creating a new product might be something that should only be possible for logged-in users. Or maybe any action should only be possible for logged-in users. That, of course, depends on your use case and which kind of app you're building. So the goal will be that we present some login screen to our users, and on that screen, users can enter their credentials and authenticate themselves with the server. So we'll send a password and an email to the server, and the server will then either create a new entry for that user and store it in a database, or if that already happened and the user tries to log in, the server will check and validate the password, and if it's correct and matches the email, well, then the user is treated as authenticated. But now the interesting part happens. How does that work? How does the server treat a user as authenticated, and how do we manage that? If you have a web development background, and if you don't, it's no problem, but if you have that background, you might be aware of the concept of sessions. In web development, you could create sessions on a server to basically store an entry on the server, in a database for example, that basically logs that a user with a given ID is currently logged in. And in your front end, so in the browser basically, you would also store a cookie which identifies that session, so which has the ID of that entry in the database, which in turn knows that this user is logged in. And then browser and server can communicate to find out, hey, the user using this app in this browser is currently logged in. This is how this would work. And I'll not go into more details here because this is actually not how this works in Flutter. Because in Flutter, and also in many web apps, but here we're building a Flutter app, you work with RESTful APIs, and these APIs are stateless. Now, this has nothing to do with stateless widgets, of course. Instead, it means that the server, the API, does not care about the individual client that connected. We don't store anything in the database that tells us that a certain user of a certain app or website or anything is authenticated. That's not how it works. Instead, the job of the API is to provide certain endpoints to which you can send requests, and then we simply return an answer. We don't want to take care about managing who's authenticated and who's not. So using a session is not the idea. Instead, you use a token. The idea behind the token is that once the user logged in, such a token is generated on the server with a certain algorithm and a certain private key that's only known to the server so that the token can't be faked. And that token is in the end a very long string which is sent back to the Flutter mobile app. Now in the Flutter app, you then go ahead and store that token on the device, not on a server, not in a database in the web, but on the device. So in this module, we'll also have a look at on-device storage. That token is stored on device because this allows us to read it from there when the app restarts, for example, because that will clear all the memory we had. So storing the token in a variable would not suffice. That would be lost when the app restarts. But storing it on the device storage, on the device hard drive, so to say, makes sure that we can fetch that token even when the app restarted. But of course the question is, yeah, what's the idea behind that token? The server now works such that for endpoints, which should actually be protected and only be available for logged-in users, it requires us to add such a token to the incoming request. So if we send a request to an endpoint, which is actually locked down, let's say the endpoint to create a new user, so a post request to a certain URL, then that request will be declined and an error will be sent back if no valid token is attached to the request. And of course, in this module, you will learn how that attachment of the token works. So only if we have a token, and it has to be a valid token created by that server with that algorithm, with that private key, which only the server knows. So only if we attach that token to the request, the server knows, okay, you got that token. The only source where you could have gotten that token from is me, the server, and therefore you are logged in because you clearly proved that earlier. So the server doesn't have to store that we're logged in, the token tells the server that we are logged in. And because of that private key, which is used for generating that token, which is only known by the server can also tell that that token is not faked or some random string, but that that token was created by this server. This is how authentication works. That's the rough idea, and that is what we will implement now in this module. We'll not focus on that server side, on the token generation part, because this is no server-side course. If you want to learn more about that, you could use a language like Node.js, and I do cover all that behind-the-scenes server-side stuff there in my Node.js The Complete Guide course, for example. From Flutter's side, we'll only have to take care about storing and managing and attaching that token. So that's what we'll focus on in this module. Thankfully, Firebase has this token creation mechanism built in, and we can easily enable authentication there and lock down our endpoints in Firebase. So we'll have a server that supports all of that automatically. With that, let's dive in.